Hey, 8th grade. So our learning target today is I can analyze a graph with multiple lines. We're going to be looking at multiple lines on the graph and comparing their slopes. What happens in different scenarios? Who is traveling faster? So it says the 3 riders below are in a race. Look at the rates and make a table for each rider. Graph the 3 lines. So we will be graphing the 3 lines. We're first going to make that table. So we have Flame. And Flame's speed is 24 miles in 6 minutes. So we really want to know how many miles is that in 1 minute. That's what we're looking for in terms of speed. So let's start with Flame. So we have 24 miles, 6 minutes. So we want to know how many miles in 1 minute. That's what we're looking for there. Now, in order for me to do that, I'm going to need to check to see if it's proportionate. Does it go through the origin 0, 0? So the question is it true that if I have not started the clock at all, that I haven't traveled at all? Yes, that's true. It does go through 0, 0. And if that's true, we can take cross products here. So we would go ahead and multiply 6 times x equals 24, divide by 6, copy paste, and we get x equals 4. So that unknown value there is going to be equal to 4. So we would say that this rider, Flame, is going 4 miles in 1 minute. That would be our speed or our rate in which Flame is traveling. Now I have 3 data points. I can always try to get more, but we'll just start with that for right now. Turtle, same thing. What we're looking for is how many miles does Turtle go in 1 minute? My data points right here say this. 4 minutes is 30 miles for Turtle. So we want to know how many miles in 1 minute then for Turtle. We would want to start with the idea of proportionate. Does it go through 0, 0, the origin? The question is, if I haven't started the clock at all, have I traveled any miles? And the answer is no. So at that point, we would take cross products. Solving. Taking cross products then, there we would have a situation of we have 4x equals 30, divide by 4, copy paste, and we get that x equals 7.5. So we have x equals 7.5 when we divide this problem up here. So we would say, well, 30 miles in 4 minutes is the same as 7.5 miles in 1 minute. That's the speed at which Turtle is riding. And then we have Cruise. Cruise is traveling 50 miles a minute. We want to know how many miles is that in 1 minute. So let's set up Cruise's scenario. We have 50 miles, 9 minutes is how many miles in 1 minute? That would be our speed at which it's traveling. We would want to know about, is it proportionate? Does it go through the 0, 0, 0? Does it start at 0, 0? Meaning, if I haven't started the clock, have I traveled at all? No, that's true of any travel situations. We'd say, yes, that's proportionate. The minute that it's proportionate, you can take cross products. So our cross products here would be 9x equals 50 divide by 9, copy paste. So we'd have 50 divide by 9. Everybody should be typing in 50 divide by 9. Gives me 5.55555 and so on. So I'm going to go ahead and round that answer then to 5.6. So we're going to go ahead and round to 5.6. So we would know that this rider, Cruise, is traveling 5.6 miles when I round that repeating decimal per minute. That's the speed at which Cruise is traveling. So we have this scenario is who is the fastest? Who is the fastest? Okay. So we have 3 data points for each rider. We could get some additional data points, which is what I would do if you were in class right now. But since it's through the video, I don't want to extend the video too long. So I'm not going to get those additional data points. We will just graph the 3 that we have for each rider. I am going to be very careful about color coding those as well. All right, so as I look at my graph, I'm going to need a scale set up. So I have my y-axis determined already for me is the miles. So here's my y. Go ahead and erase this up here so that you can see clearly that that is my y-axis. And that would be representing our miles. And then we have our x-axis down here, and that's representing our minutes. So our miles and minutes. We would say 0, 1, 2, 3, 4, 5, 6, 7, 8. We can only get 8 on our graph down here. So I'm actually going to go, let's see, minutes. Yeah, I'm only actually going to go by 2s, 0, 2, 4, 6, 8, 10, 12, and so on. We're going to just go ahead and use that. All right, and then working on our y-axis. Our y-axis ranges for all the riders. We would need to look at all the y's because remember, they're all going in the same graph. So we're comparing all of our y's. Looks like our smallest y so far in all of those is 0 because it's the origin. Looks like our biggest y is 50 right over here. This one right here. So as I start to solve this y-axis scenario, I think I might go by tens. 10, 20, 30, 40, 50. Let's see, could I go by 5s? 5, 10, 15, 20, 25, 30, 35, 40. That's not going to work. I'm going to go by 10. So we have 10, 15, 20. Whoops, messed that up. I meant to say go by 10s and I went by, I changed the scale. Let's start over. 10s, 10, 20, 30. Then we have 40, 50, and that would be enough for us right there. All right, so that's our y-axis, the miles compared to the minutes. We're looking for speed. So as we start to set this up then, we're going to start with this rider over here, Flame. Flame is has a data point of 0, 0, of course, at the bottom. I'm going to start with that origin on the very bottom of my table. And then Flame has a data point of 1, 4. So we're going to go right 1, up 4, which becomes kind of a guessing game, unfortunately. And then Flame has a data point of 6, 24, over 6, up 24. So we have this line here, and this is Flame. That's the speed at which Flame is traveling. All right, then we have this next rider, which is Turtle. Turtle, of course, has 0, 0 as well as the origin. Turtle has a data point of 1, 7.5. So over 1, up 7.5, again, becomes kind of a guessing game. And then over 4, up 30. So over 4, up 30. That one's in a nice data point there, a nice little spot. Whoops, trying to draw this straight line. Kind of hard to do with what I'm writing with right now. So that's Turtle's graph. You can see that Turtle is traveling faster because the line is steeper, which means the slope is greater for Turtle. And finally, we have Cruise. Cruise has 3 data points as well. I'm going to plot those in blue. We have 0, 0, the origin. They're all starting in the same spot. We have 1, 5.6, kind of hard to graph. And then we have 9, 50, 9, up 50. So it looks like it's kind of in the middle there. So there we have Cruise. All right, so there's Cruise. You can see that according to our graphs, Turtle is traveling at the fastest speed, which is a little ironic that the Turtle is moving the fastest, and then Cruise, and then Flame, based on the steepness of their lines or their slopes. Now, we're just eyeballing that. We can easily say that Turtle is the fastest based on steepness, but we need a measurement, like a number, to say what is the measurement or the slope. So as I do that, I have a couple options. I could run those data points to get my slope, or I could recognize that anytime you have a unit rate, I'm going to go back to this table here, anytime you have a unit rate, it is the slope. So there's my slope, and there's my slope, because they're all measurements out of 1. So I'm going to use that as my slope, just to speed up the video slightly. The other option, guys, is you could use these data points and go y2 minus y1 over x2 minus x1 to get the slope. So I'll go back through the 3 possible ways. You could go to your graph, run it to get your slope m. You could recognize that there are unit rates right here, that they're out of 1. That is your slope. That's what slope is. Or you could go ahead and use your 2 data points, y2 minus y1, and get it. So I'm going to go ahead and say I'm going to get mine from right here, my unit rate. So we'd say 4 miles in 1 minute is my slope. I'm going to say 7.5 miles in 1 minute is my slope for Turtle. And I'm going to say 5.6 miles in 1 minute is my slope for Cruise. So those are my 3 slopes. So the equation then is in the form, of course, of y equals mx plus b. Y equals mx plus b, and y equals mx plus b. Now, if that was too fast, go ahead and try to catch up there, and then we're going to move on. All right, so using substitution here, we have Flame over here on the left. We're going to say that y is a stop sign. The slope is 4. X is a stop sign, and the plus B actually in this particular case becomes plus 0. Why? Because it's starting at the origin. So my slope for flame is y, or my equation for flame is y equals 4x. Moving on to a turtle here in the middle. We have y stop sign. My slope is 7.5, x stop sign, and my y-intercept is also plus 0 because it's starting at the origin. There's my equation for turtle. And then on the right, we have y stop sign. My slope is 5.6. We have x stop sign. There's my equation for cruise as the y-intercept again is 0. So all of those y-intercepts turn to 0, so we don't need those. There's my 3 equations for flame, turtle, and cruise. Okay, so now, moving on, it says use the equations to show what mile each rider is at 23 minutes. Now, you'll notice in my table, if I look up at my table, I cannot see 23 minutes on my table. Or, pardon me, my graph. I can't see 23 minutes on my graph. So I'm going to use my equations as the directions say. The directions say to use the equations. I can't get it from the graph. My graph doesn't extend that far. That was intentional. I did that intentionally so that you couldn't use it. Here's my equation. What's happening at 23 minutes? Well, 23 minutes is our x. Because minutes is our x, we're going to substitute. So we have 4 times 23. So what happens at 23 minutes becomes 4 multiplied by 23. Go ahead and type that in your calculator. You have 4 multiplied by 23. And you end up with 92 miles. 92 miles. So our coordinate is 23, 92. That's minutes and miles. So flame at 92 miles has traveled 23 minutes. Let's do the same information for turtle. Again, if I'm going too fast, go ahead and pause that video. All right, for turtle, we have y equals 7.5 multiplied by x. We want to know how far has turtle traveled in 23 minutes. We're going to take that x value of 23 and we will substitute in for the x. So we have 7.5 multiplied by 23. We have 7.5 multiplied by 23. Everybody should be typing that in. 7.5 multiplied by 23. Okay, so we end up with 172.5 miles. 172.5 miles. So turtle in 23 minutes has traveled so much further than flame. 172.5 miles. I don't have room to write that data point, so I'm not going to. And then we have cruise. Cruise is traveling at 5.6, because I rounded it, because that's that repeating decimal, 5.555 times x. What's happening at 23 minutes for cruise? So we're going to go ahead and type that in. This will be a little bit tricky based on rounding there. So we have 5.6 multiplied by 23 gives me 128.8 miles. Okay, so you can see even here who is traveling the fastest clearly is turtle. Turtle is still beating everybody. Cruise is in second place and flame is in third place. We saw that up in the graph. We can see that in the equation based on the amount of miles they've traveled in 23 minutes. Now again, if I'm going too fast, pause the video. If you have a sub today and you need to go back and rewrite anything, please politely and respectfully ask the sub to pause the video. In part B, we're going to use the same equations. So essentially, we're going to take this equation and move it down. I get the beauty of doing that on the smartboard. You do not. So go ahead and write it again. Go ahead and write it again. Whoops, that X looks like it's attached there. Okay, so I'll give you time to write that again. Okay, so here we go. Using substitution then, we have y equals 4x. And we want to know, using the equation, what happens when the rider goes 140 miles? That's our y coordinate this time. Using substitution, we're going to substitute 140 in for y. Hand method's going to kick in, so we're going to end up with 140 equals 4x. Hand method. Take our hand, cover the variable. We're going to divide by 4, copy, paste. Divide by 4, copy, paste. We have the hand method here. We're trying to solve for the minutes. The minutes is the variable x. So we have 140, which is the miles. Divide by 4, copy, paste. Go ahead, type that in. Gives us 35 minutes. So what we know is this. 35, 140 is a coordinate. 35 minutes, 140 miles would be our data point. Okay. So doing the same thing then for turtle. Substitution then for turtle. So we're going to take the 140 and we're going to substitute in. So we have 140 here equals 7.5 multiplied by x. What we're trying to do is find the value of x. X is the number of minutes that turtle has traveled in 140 miles. So we take the y out, put 140 in, because that's the value there. Hand method kicks in, divide by 7.5, copy, paste. So we have 140, divide by 7.5. I'm typing that in at the same time. Might be a repeating decimal, I believe, if I'm going by memory here. 140 divided by 7.5. Yes, it's a repeating decimal, so let's go ahead and round it to the nearest tenth. So we end up with the x value is equal to 18 point, and I'm going to round 7 minutes. So we'd have 18.7 minutes in 140 miles. Okay. Let's take a look at cruise. Cruise is traveling over here at 5.6 miles a minute. So if we substitute in 140 miles, how long does that take? Hand method kicks in, divide by 5.6, copy paste. I'll let you catch up there. Go ahead and get that all worked out. I'll be typing in at the same time. I'll give you a chance to write. Stay with me, 8th grade. I know this is a long lesson. We're already at 16 minutes. So we have 140 divided by 5.6. Because I rounded, it gives us 25. So we end up with a situation of cruise at 25 minutes has traveled 140 miles. So we found some different scenarios. In part A, we were given the minutes and asked to find the miles, given the x, asked to find the y. In part B, we were given the miles, the y, asked to find the x, which actually part B then turns into the hand method. All right, so probably the toughest problem of the day right here is part C. This will be our last part until we have our summary here. So how far have turtle and cruise gone when flame is at 80 miles? So this tends to be kind of a confusing question. So what we know for sure is that flame is at 80 miles. We'll deal with these two after, but this is really the only data point I have. Flame's equation, if I look above, flame's equation is y equals 4x. Okay. So we're asked about what happens when flame is at 80 miles. Well, miles is the y, so we're going to use substitution and plug miles in for y, because y is the miles. So this is the setup that I have. Substitution, y comes out, 80 goes in, and we solve using the hand method. We're going to divide by 4, copy, paste. So I end up with 20 equals x, which is the minutes. So our data point is this, 2080. In 20 minutes, flame has gone 80 miles. Go ahead and catch up if that was too fast. Pause that video if you need to. Okay, we've not really answered any question. All that we know so far is that flame has this data point of 2080. XY. Minutes, miles. It's asking you, how far have turtle and cruise gone when flame is at 80 miles? So we know that turtle has traveled so we want to know what is true when they're traveling at 20 minutes. 20 minutes is the equivalent of 80 miles for flame. So what we would say then is, what's going on with turtle at that same time? And what's going on with cruise at that same time? I'll let you catch up there. Okay, stay with me, 8th grade. I know we've been talking for a long time here. We're at 19 minutes. We're almost done, I promise. Turtle's equation is as follows. Turtle is traveling at a speed of 7.5 miles every minute. So we want to know what is happening with turtle at that same time, at the time of 20 minutes. We know what happened with flame. Here's flame's information. At 20 minutes, flame's at 80 miles. Where is turtle at that same time frame? So we're going to substitute 20 minutes in for x, because we want to know where is turtle at 20 minutes. We know where flame is. Flame is at 80 miles. Where is turtle? So we have 7.5 multiplied by 20 minutes. And we would find out that turtle, 7.5 multiplied by 20, is at 150 miles. So that means at 20 minutes, 150 miles. Okay, so clearly turtle has traveled further. And what about cruise? Where is cruise? Well, cruise is traveling at 5.6 miles a minute. So where is cruise at that same time of 20 minutes? So we would substitute the 20 also in for cruise. Notice we substituted in for turtle, we substituted in for cruise, and we found it over here. 5.6 multiplied by 20. So we'd have 5.6 multiplied by 20 gives me 112 miles. So cruise at 20 minutes has gone 112 miles. Okay, so if we look at these three data points, very important data points, all of them are 20 minutes, all three of them. We want to compare the total amount of travel for all three of those riders. Flame is at 80 miles, Turtle's at 150, and Cruise is at 112 miles. So we've answered the question of where are all three of the riders at 20 minutes. Okay, so that is our lesson today. It's how do we work through table graph equations. So just a couple of things. Remember, slope is a unit rate. So for that situation, we could have gone y2 minus y1 over x2 minus x1. You still could do that. You just need 2 points to do that. Or you could rise run, the hotel analogy. Or you can recognize that it's a unit rate. A unit rate means this, that there's a 1 in the bottom. This is the key. So some value over 1. You can also use that, which is the one I use because it's a little bit faster. And just remember the last piece, and I know you're still writing here, that tables, graphs, and equations have this system that works together. So they work together. It's like this triangle method of that they all work together. Okay, table, graph, and equation work together. All right, 8th grade. So your homework for tonight is to do page 20. Make sure you've labeled everything. You might want to color code your graphs like we did in class because it's a little bit easier to see. You might want to just use the unit rate as your slope. It's up to you. If you need to watch the video again, go ahead and do that, but your homework is page 20. Have a fabulous night, 8th grade.